So this question is from the 2023 AS level pure math paper, and I think it's really interesting because I haven't done a question like this, especially on this channel before. So let's have a look. We are going to find the coefficient of x to the fifth power if you expand this. And notice we have this thing to the sixth power. So there must be a smart way to do it. Do not multiply all the things that we don't need. So let's investigate first. At first, right here, we have two terms, 5 plus 8x squared. And imagine if we do expand this out. What do we really care though? Well, imagine we have this already. Then we will have to take the 5, multiply with something here. Remember, we're trying to get the x to the fifth power. And this is just a constant, it has no x. So we must care about the term that was x to the fifth power in this expansion. And we must have the x to the fifth power term because this thing is to the sixth power. Okay, then we will take this. It has x squared term already. So what do we need from here? Well, the answer for that is x to the third power term. Together, when they multiply, they also contribute to the whole coefficient of x to the fifth power. And then for the rest, we can care less. But now the question is, how are we going to figure out the coefficients of x cubed and x to the fifth power in this expansion though? Well, the key is to use the binomial coefficient. And that is the binomial theorem. Let me write it down right here for you guys. Note, if today we have two terms, a and b, I'm just going to write it as a plus b. Even though this is a minus, but b could be negative. Raised to the nth power, then we are going to get the following. It's going to be a sum, a lot of things adding up. So I'm just going to write down the summation. I will use the index k, starting at 0, going to n. And then this right here is the binomial coefficient. We can write it as n choose k. And another common notation for that is n choose k in the parentheses form without the fraction bar. Then we are going to multiply by a raised to the n minus k power, and then times b raised to the k's power. So one thing to remember is that these two powers, they will always add up to be n. Keep that in mind. Okay, now for this term, we have to think about how to get the x to the third power from here, right? So let's start with this part first. So that means we must have negative 1/2 x. I know the marker is not showing. Just have to keep writing down a little bit. See? So you have to make it work. Anyways, take this term with that negative, and we have to raise that to the third power. That's how we can get x to the third power from here. So this part is like b to the k. Now, the previous part right here, it will be this, which is 3. And remember, the powers have to add up to this, which is 6. So 3 plus 3 will give us 6. Now, the n choose k part. N is 6, so we do 6 and then choose. What's k? Well, you can just look at this number here. So 6 choose 3. Yeah, just like that. Okay. And then for this, same thing. We have x to the fifth. Starting right here, so we have negative 1/2 x and then raised up to the fifth power, and then takes 3 to what power? 1, yes, because they have to add up to 6. And then one more, we will have 6 choose 5. Alright, so these are the coefficients of this and that. So now let's multiply this out. First, we take the 5 times this, which is 6 choose 5, and then 3 to the first, and then right here, let me write it as negative 1/2 to the fifth power, and then x to the fifth power. Okay, and then we need this times that, so we just have to add it with 8x squared times this right here, which is 6 choose 3, and then 3 to the third power, and then let's write this as negative 1/2 to the third power, and then x to the third power. And of course, they produce the x to the fifth power for us. Now, just real quick, how do we compute the binomial coefficients, the n choose k number? Let me just write this down right here for you guys. So note, if we have n choose k, this right here is equal to n factorial over n minus k factorial divided by k factorial. So that's the formula way to do it. But this is how I like to think about it. So if we have 6c5, this is actually the same as 6c1, but I will look at it like this. What I do first is I will start with 6, and then on the top, make sure we have a total of 5 numbers, starting with 6, and then it goes down by 1 every time. So 6, 5, 4, 3, 2, right? 5 numbers, and then we are done. And then right here, on the bottom, just do 5 factorial. 5, 4, 3, 2, 1. And then notice that a lot of these things will cancel, which is quite nice. The answer is just going to be 6. So this right here, it's equal to 6. As of for 6 choose 3, start with 6, and then write down the total of 3 numbers, so 6, 5, 4, and then over 3 factorial. 3 times 2 times 1, 6 is the same as that, so you can cancel that out. So that will be 20. So this right here is 20. And for the rest, this right here is just 3. This right here is negative 1 over 32. This right here, my arrow is wrong. This right here is 27. And then this right here is negative 1 over 8. Okay, let's see what we are going to have. Right here we have 5 times 6 is 30 times that is 90. 90 over that, so it's negative 90 over 32. And then x to the 5th power. And then right here, this and that cancel. It's negative though, so it's minus. And then we have 20 times 27, which is 540. And then, of course, x to the 5th power. So let's reduce the fraction real quick. This right here is 45, and then 16. And just get a common denominator and then just add them up and maybe use a calculator, which is allowed on the test. It's quite nice. So I'm going to tell you guys the answer because I have the answer key, which is better than the calculator, which is negative 8685 over 16, x to the 5th power. And we're just looking for the coefficient. So this right here is the answer. That's it.